Bonjour monsieur,
Salut, ça va?
ça va, j'étais en train de reprendre un petit peu ce qu'on avait eu pour le devoir maison.
Je regarde aussi. Donc, qu'est-ce que vous voulez? Est-ce que vous voulez qu'on fasse chaque question en ordre?
Euh,
Ou il y a des questions particulières?
169 000 $ pour leur duplex, même l'avant sur l'indemnisation définitive.
Excusez-moi. J'essaie de retrouver en fait le lien, le fichier, mon fichier corrigé. J'arrive pas. Je crois que c'est dans mes mails.
Ah, d'accord.
C'est pas ça. Excusez-moi, vous savez, c'est où qu'on, ah, c'est dans Notes qu'on peut voir le. Il n'y a pas un moyen de récupérer le. Vous aviez envoyé les devoirs corrigés.
Oui, bon, j'ai rendu les devoirs et je crois que vous l'avez envoyé par... euh, en fait, bonjour à tout le monde. Je vois qu'il y a beaucoup.
Ah, j'ai pas vu. Bonjour.
Donc, est-ce que c'est tout pour le devoir?
Les questions?
Ouais, je vois Alina, Grégoire, c'est pour les devoirs aussi.
Oui, on est aussi venu pour vous parler du devoir un peu, essayer de voir ensemble pour les questions.
Très bien, ouais.
Moi aussi.
On va attendre un peu. Ah oui, 31. Donc, vous préférez en anglais ou en français?
En français de préférence.
Très bien, on va faire en français. OK, ben, ce que je vous suggère, c'est on peut y aller en ordre et voilà, vous m'arrêtez si vous avez des questions, peut-être. Et peut-être que ce que je peux faire, c'est ouvrir une page avec des calculs et ouvrir les questions à côté. Voilà. Ce qui était plus difficile, c'était la première partie ou la seconde partie? En passant, si vous voulez, ce que je vais faire, je vais le laisser enregistrer. Comme ça, je vais pouvoir mettre ça sur le site après. OK. Ricarden Model. Ah oui, donc attendez, je vais partager le truc. Donc, on va... OK. Donc, vous pouvez voir, donc j'ai les questions ici, je vais faire les réponses à gauche. Donc, on a... donc, les productivités, c'est A LC égale 4. ALF égale 2. Et on a ALC étoile égale 5 et ALF. Je vais faire mes questions. ALF étoile égale 3. Ah, c'est qui a l'avantage absolu. Donc, c'est réponse, c'est toujours le pays dans lequel la production coûte le moins cher. Le plus bas. Alors, on n'a que ALC, que ALF, que ALC Astérix. Et on n'a que ALF, que ALF Astérix. Donc, on a un avantage dans les deux. Ça, c'est bon? En fait, donc, je le fais et puis vous m'arrêtez si jamais vous avez un souci. D'accord? Ensuite, B. Quel pays a un avantage comparatif? Les tissus. Donc là, c'est évidemment ce qu'on regarde, c'est donc le coût de faire du tissu par rapport au coût de faire quelque chose d'autre. Donc, ici, ce qu'on regarde, c'est par exemple donc on a ASC divisé par ALF. Donc, le coût d'opportunité du tissu. Ça, c'est égal à 4 sur 2. Vous voyez que c'est le coût d'opportunité parce que donc, pour produire une unité de tissu, je dois utiliser ALC de travailleurs, donc 4. Et donc, combien de food je dois sacrifier? Ben, ce que j'aurais pu faire aussi, c'est utiliser mes travailleurs pour faire du food. Donc, comme j'ai besoin de 4 travailleurs pour faire 2 au lieu et pour faire du tissu et 2 travailleurs pour faire du food. Donc, ça veut dire que je dois sacrifier 2 unités de food pour obtenir une unité de tissu. Donc, c'est pour ça que c'est le coût d'opportunité du tissu. Donc, plus c'est élevé, plus ça coûte cher à faire du tissu. Et donc, j'ai ALC sur ALF, qui est le coût d'opportunité du tissu spring, égal à 5 sur 3. Ça, c'est 1.6. Donc 2 est plus grand que 1.6. 7. Donc, ça veut dire que Foring a un avantage dans le tissu. Donc, le tissu est vraiment très cher par rapport au food at home et il est moins cher par rapport au food at foreign. Donc, foreign a un avantage comparatif. Donc, dans le tissu. Et home, un avantage comparatif. Dans la nourriture. Donc ça, c'est la base, c'est ce qui nous permet d'avoir du commerce dans un modèle aussi simple comme ça, où il y a tout est linéaire finalement, tout est il n'y a pas d'économie d'échelle ou rien. Ok, maintenant ça peut devenir plus intéressant. C par exemple, qu'est-ce que c'est C?
Excusez-moi, monsieur.
Ouais.
Est-ce que vous pouvez peut-être donner des petites explanations en anglais, car c'est pas ma langue maternelle et je comprends pas toutes les choses que vous disiez.
Ah, ok, d'accord.
Ouais.
Ben, ok. Yeah, so maybe I should continue. I thought French would be good for everybody, but yeah, okay, I'll try to mix both. So here what I'm saying is, so
J'ai compris A, j'ai
Ok.
seulement des questions pour
B
B.
is coût d'opportunité is opportunity cost. So I hope it's the right answer. Donc, ouais, c'est ça. Okay. So I'm not mistaken. So yeah, personally, I find that the challenge for trade is that you always get these productivities in one thing or the other at home or abroad. So it's yeah, you have to keep track of all these things. It can become confusing. So that's opportunity cost of So what I was saying there is, why is it the opportunity cost? Well, it's if I want to produce 1 unit of, say, of clothing at home, I need 4 people. What could I have done with those 4 people? I could have produced actually 2 units of food, because 4 divided by, I just need 2 units of food. So 4 divided by 2 is 2. So producing 1 unit of clothes at home requires me to sacrifice 2 units of clothing. So that's why the opportunity cost is 2. So the higher the opportunity cost, then the worse it is. So the more costly it is. So it means that if you have a high opportunity cost in something, then you should produce the other thing. So this is why 2 is higher than 1.67. So home is better at food and worse at clothing. Yeah. C. Yeah. Home countries, the production positive frontier, draw food on horizontal axis and clothing on vertical axis. So for the PVF, we use this formula that we have. So we know that. So the people use that home to produce food are going to be LF, plus the people used to produce clothing LC are going to be equal to L, the total number of people, right? So I get, and how much people do I need to produce food? Well, the quantity of food that I produce multiplied by how much people I need to produce my food. So it's AF is F, then QF, if I'm not mistaken. plus ALC. This is equal to L. And so now if I want, oh yeah, so let me draw the home EF with, what did I say? Clothing. And so to do that, I want to isolate clothing. Okay, so I want to express clothing, the quantity of clothing as function of the quantity of food. So what I'm going to do is the following. So I'm going to subtract food here. And then, so I can divide this by, sorry. This is A. And then I'm just going to divide by AS. So here I can draw a function of QC as function of QF. So this is my production possibility frontier. So clothing is on the y-axis. It's a function of what I have on the x-axis, which is QF. So let us go again and draw this. So I want like this. Oh yes, I can put numbers on what I have. Okay, so this is L is at home. Do I know it's? I think it's 100. That's, oh yes, 100. And the ALC is 4. And LF is 2. So then what I get is 25 and okay, so one way to draw it is to ask yourself what is the intercept when QC equals 0, and so you get intercept for QF, and then what is the intercept when of QC when QF equals to 0. So if say QF equals 0, and I get QC equals 25, and if QC equals 0, then I get 0 equals 25 minus QF. So let's multiply everything by 2. So I'm going to get 50. All right. So this is a neat trick to draw stuff easily. So I know that I'm going to have, so it's a line, the production possibility frontier. And I get, so the intercept is 25, 0 and 50, 0. So I said I wanted to have, yeah, okay. So I said the clothing on the vertical axis. And I want food here. So food that I'm going to have, so if floating equals 0, then food equals 50. So let's just, okay, what we can do is try to make better. So let's say this is 25. So if your drawing is good, then it makes everything very much easier. And so this is 25, so this is 25 as well. So you see I have 2 points. So when QF equals 0, QC equals 25, so QF, oh yes, this should be, sorry. See, this should more or less. All right. So when QF equals 0, QC equals 25. And when QC equals 0, then QF equals 50. So that's the trick to draw it. Let's try this here. Yeah, so maybe this is not the best. Let's use red. That's the PDF. All right, does that make sense?
Yes.
So yeah, I can say it in French real quick. Donc, ce que j'ai fait, c'est que je me pose la question quand, donc, pour tracer la Production Possibility Frontier, je dois connaître c'est quoi les possibilités de production. Ici, donc, L, c'est la quantité maximum de travailleurs disponibles, c'est 100. Et je sais donc que les travailleurs vont être ou bien employés dans le food ou bien dans le tissu, dans le... Ah, c'est ça, dans le tissu, c'est. Donc, je peux remplacer, donc ça, c'est le nombre de personnes dans le tissu, c'est la quantité de tissu produit fois le nombre de travailleurs nécessaires pour produire de tissu. Même chose pour food. Et ensuite, ce que je souhaite, c'est exprimer la quantité de tissu produite en fonction de la quantité de food produite. Donc, ce que je fais, c'est j'isole QC ici. Donc, j'obtiens ça, QC égale 25 moins demi QF. Et ensuite, pour le tracé, ben, je me pose la question, quand QC égale 0, quelle est la valeur de QF? Quand QF égale 0, quelle est la valeur de QC? Comme ça, je peux tracer les deux intercepts. Oui, and at the exam, if I ask you to draw stuff like that, then yeah, I like when you put numbers on the axis, so I know that the numbers make sense. And yeah, I tell you, for you, if you draw it well, it helps a lot later computation. Okay, so that's yeah, so now there's, so I forgot to, so it's not C, let's say it's C prime. So C number 2. Yeah, I added one question and I forgot to. Okay, show that if Ohm's representative consumers as utility square root, then the demand is this. Okay. So this is a bit more advanced, but still I more or less showed how to do it. So this is how to derive a demand function from a utility function. So I have utility function at home. So F C. And then it's equal to square root of QF. Okay, so I showed different ways of doing it. How should I do it? Yeah, so one way to do it, I'll just show one way and you can see the other in the exam. So I think I showed 3 ways of doing it, right? Yeah, yeah, I was quite ambitious. So but I changed my function in the solutions. So let's just keep this one intact just to show you another way. So one way to do it. So at the optimum, so I know that the marginal rate of substitution. Okay, right. I'm just going to write it. So the marginal utility boom divided by the marginal floating. So that's the marginal rate of substitution is equal to the relative prices, so price of food divided by the price of clothing. This is something I know. And so I'm not going to go into detail, just use this thing, it works. So if I'm asking you find the optimum using a utility function, then this is a way that you can do it quite easy. And this, of course, is the derivative of this utility function with respect to the quantity of food. So it's how much extra utility I get from 1 unit of food. And this is how much extra money I have to pay to get, oops, sorry.
PC.
Yes, exactly. Yes. So let's do that. So I get, this is going to be, so let's write this way. That's a bit easier maybe to do it. So marginal utility of food is equal to U QF. So that's equal to, so I take the derivative, so I get 0.5 minus 1. And same thing for this. So here, yeah, I take the derivative with respect to that part, which is 0.5, then 0.5 minus 1. You'll see that we get the same thing that we got for the if we transform the utility function. And then so this is equal to like this. So that's equal to and then 0.5 disappears with that 0.5. So I'm just getting a minus 1 there. So I'm just going to get QF at the denominator. And here 0.5 cancels out the 0.5 of that one too. but I have so -1 there. So what I'm going to get at the end is QC at the numerator. Right. So this is exactly the same as as I showed that we get in the as solution if we transform the utility function. So it works as well. Yeah, and now yeah, this is equal to the relative prices if what we have is yeah. Normally what we have is something like F times QF plus PC times QC for some income, for instance, and but here, what do we have? Well, we know what the situation is so yeah.
Excusez-moi, j'ai un petit problème avec les exposants -1, j'ai pas compris.
Ok. Donc, pour prendre, est-ce que vous avez déjà fait une dérivée? Par exemple, si j'ai y égale x carré, est-ce que vous savez comment je fais des y, des x? Ça, vous avez déjà fait une dérivée?
Sûrement, mais là, j'ai pas mémoire de ça là tout de suite.
Ouais. Tous mes respects de suivre le cours, hein, parce que je fais plein de maths tout le temps et je peux imaginer la difficulté. Donc, quand vous faites une dérivée d'une fonction avec un exposant comme ça, donc dy dx, ce que vous cherchez, c'est, par exemple, j'ai la dy x carré, ça ressemble à ça. Je vais vous dessiner ici. Donc, quelque chose comme ça ici. Donc, ça, c'est notre axe des Y comme ça, notre axe des X comme ça. Et ce que vous cherchez, c'est la pente ici. Et donc, dy sur dx, c'est de combien y change, ça c'est y, quand x augmente d'une unité. Et la règle, c'est quand vous avez une fonction avec un exposant comme ça, vous faites, c'est égal à l'exposant, vous le multipliez par l'exposant, c'est 2, et vous soustrayez 1. Donc, si vous avez, par exemple, je vais vous mettre un autre, donc y égale x cube. Donc, dans ce cas-ci, vous auriez y dx égale 3x 3 moins 1. Donc, ça serait égal à 3. D'accord? Et ça ici, c'est égal à x à la 2 moins 1. Donc, c'est égal à 2x à la 1. Ça va? En fait, donc, c'est les règles de prendre des dérivés. En fait, si j'avais su que votre niveau de mathématiques était à ce point, j'aurais probablement essayé de mettre un peu moins de maths dans le cours. Bon, voilà. J'ai fait le cours quand j'ai fait le cours, donc désolé d'en avoir mis autant, mais je le saurai pour la prochaine fois. Et ensuite, donc l'autre chose à savoir, je pense que ce qui vous confond, c'est comment je simplifie de ça à là, non?
Déjà, c'était de comprendre en fait le -1.
Ouais, donc c'est ça. Donc ça, c'est juste la règle pour prendre une dérivée d'une fonction avec un expo, tout simplement. Et ensuite, quand j'ai quelque chose comme x à la a, par exemple, ou x à la moins a, donc c'est égal à, quand j'ai l'exposant ici qui est négatif, ce que je peux faire, c'est je peux simplement diviser par x à la a, et donc c'est égal à 1 sur x à la a. Donc c'est exactement Donc, quand j'ai un moins ici, je peux simplement le mettre au dénominateur, mais alors le moins disparaît. D'accord? Et quand j'ai, par exemple, x à la moins a, donc c'est égal à x à la, tout simplement. OK?
OK.
Donc, bon, ça c'est...
Ah, mais non, mais c'est pas. Moi, j'avais juste besoin en fait, rien qu'avec les formules, ça va m'aider à comprendre la
D'accord, ouais, c'est ça. Donc,
logique. C'est juste que à la voir fait que quand je les cherche et que je suis perdu, je peux passer beaucoup de temps à chercher quelque chose. Mais avoir les formules, ça m'aide
d'accord, très bien. Ben, je vous fais
beaucoup.
ça. Donc, vous avez ma parole. Tout ce que vous pourrez avoir à faire à l'examen, c'est des dérivés de fonctions comme ça ou et des histoires de règles d'exposants. Donc, par exemple, si vous aviez ça, donc, x à la a sur x à la b, ben, c'est exactement comme si vous aviez x à la a fois x à la moins b. Donc, c'est exactement comme si vous aviez x à la a moins b. Donc, c'est encore la même règle ici. Donc, ça, c'est bon, je vous dis, c'est les genres de règles que vous pourrez avoir besoin pour l'examen. OK, donc là, je vais vraiment continuer. Donc, ça, c'est ça. Qu'est-ce que je voulais écrire ici? Ah, c'est ça. Donc, for consumers. Donc, so if a consumer has to choose between two goods and the relative price is PF and PC, then this is how it looks. So here the consumer has some income to spend that can be spent on some quantity of food, but that is going to be a price PF. So the total spending on food is PFQF. And for cloth, it would be PCQC. So now, so in the domestic market, with no trade, that's in autarky. So we don't have this situation. So our what we have is, of course, ALF and ALC. But then, so what you're going to get is that so we're going to get this equals ALF over ALC. So what's the price, quote unquote, of producing of buying food? Well, it's the price of producing it. And what's the price, quote unquote, of cloth? Then it's again the cost of producing it or the labor requirement. So this is what you get. So yeah, but anyway, so I'm not there yet. So now the only question was yeah, so the question was yeah, actually I'm already done, so I could just finish it here. So we get that so what we said is PF plus PC. And then so that's QC over QF. Right. So so essentially that's the only thing you really need to answer for this. And then of course that gives you equals 1 over and then you see what I did there. I put 1 over the inverse of these, so 1 over DC over PF. So you might be wondering why we care about this form right there. Oh, right. I think what I was asking exactly is exactly the opposite. So QF over C equals so you might be wondering why we care about this, why we show it in this form rather than just this form, which looks simpler. It's just that we want to say something like, yes, how much people are going to ask to buy food as function of the quantity of or as in proportion to the quantity of clothing, as function to the price of food in proportion to the price of clothing. So you see, we want food at the numerator and food at the numerator. So that's the reason we show it this way. All right. So this is it. So my only purpose there is to sort of justify how you would find a demand function, because sometimes I come up with, say, oh, this is what people ask. So of course it makes sense that, say, if food is more expensive relating to clothing, then people are going to want to buy less of it. So it makes sense. But so here I wanted to show what how you would get that from, say, a utility function, how economists would derive this from a utility function. Right. And then what's neat then is that you can just plug in the consumption in autarky and then the consumption after opening to trade, and you can really see that yes, people are happier, they have a higher utility. Okay. So yes, so this you don't really have to care about that, but yeah. So that was C. Okay, so D is the labor constraint. Find consumption of food and clothing. All right. Then, so all you have to do is, so we need the constraint is that one. That one here. Labor constraint. And now we have this, so we have two unknowns, QC and QF, that we want to find. But now we have a demand function. So we have and we know that at home, the relative prices are a function of the technology. Constraint. So as we said, so this is if you're some consumer and you have some budget, but so in the Ricardian model, this is our constraint. So the relative price, PF over PC, are going to be the relative productivity ALF over ALC. So, PF ALF over ALC. So does that make sense? So you see that if I was some consumer with some budget constraint, then this the slope of this would be the relative prices, and now the slope of it is actually, so it's, I can show it here, it's yeah, minus 1/2. It's so the slope is minus AL F divided by ALC. Yes, sorry, that's not super easy to express a nice fraction with this, but yeah, get the point. So yeah, the relative prices are the relative cost of producing it. So more people you need to produce something, then the more expensive it's going to be. Okay. So yeah, so we have two equations and two unknowns. Unknown. So we can just substitute one and the other. So what I can do is say, yeah, this. All right, so I could express QF as function C. So with using this one, for instance. So here you see what I did. I just multiplied by QC on both sides. And then I re-multiplied by PC over PC. So this is what, or rather, sorry, I use that one and ALC and return the denominator. So this is the expression I get. So now I can use this QF, this new QF inside of my labor constraint, and I'm going to get an expression for QC. So I substitute QF, so I get this, and then it's just algebra. So ALF divided by ALF, that goes away. So what do I get? I get QC ALF and QC ALC, QC LLC. So I get 2 QC equals L, QC equals L over. So, and I can substitute the numbers. So that's 100 divided by 2 times ALC, which is 25, or it's 4. So that's 12.5. All right, and then I can just use, say, this to substitute to find the other. So so QC, I know it's here L over 2 ALC. So ALC disappears because that's at the numerator and the denominator. So I get ALF. And then that's equal to, let's use numbers again. So that's 100 divided by 2 times, I think it's 2. So I get 25. So that I know that I should be where? I think I'm going to be there, right? QF is 25, so I'm there. And QC is 25 divided by 2, so 12.5. So this is slow. And this is consumption. If I don't trade at all. Okay, so this is how you find it. Questions about that? No, so again, this, what you do is you get 2 equations, one domain equation, one constraint. And then you so you use one to substitute the other, and then it gives you the solution.
I just have a question. You wrote let's express QC as function of QC.
Oh, sorry. Yeah, QF as confusion.
It's QF. Okay. Thank you.
So if the open to trade, in which range is the relative price going to be? Okay, so then this is so I'm going to get what in at I know that computed there, so they are going to be between the relative country. So I'm going to add that. So this equal to P over PF. And right, so for trading to make sense, then the relative price internationally must be within this range. Otherwise, if PC over PF was even smaller than ALC over ALF, for instance, then, well, actually, maybe, so does that make sense? So ALC over ALF equals to 2? Yeah, okay, it makes sense. Sorry, so I was just having some, of course, if ALC over ALF was actually smaller, yeah, exactly, that there was a mistake. So yeah, why do I know that? Well, because of course I've just computed it. So 2 and ALC star over ALF star equals to 1.6. Yeah. So of course it has to be on this side. Yeah, so we know that the relative prices at internationally must be between the two. Otherwise, say for instance, if the relative prices were 2.5, then it means that so both would find it optimal to specialize in the same production. So that wouldn't make sense whatsoever. So they must trade with some price that's in between the two prices. Does that make sense? So stop me if you have questions on this. Yeah, so another way of saying is, so this is going to be the relative price at home in Turkey, and abroad, you know that the relative price would be a bit like this. So I don't know, it depends, the place depends on the size of the country, but you know that the relative price would be less, this would be 2 over 4, 1 over 2, and this would be 2 over 5, so 1.6 it would be. Yeah, it would be a bit more like this. So then the relative prices would be somewhere in between these two extremes. So I think most of you got it. But yeah, it's possible that they are exactly equal to one or the other. So I don't want to exclude the boundaries, but it depends. In the Ricardo model, you can have extreme situations. So F. Okay, so now we are getting into more difficult territories. So assume international for food is like domestic demand, meaning that both at home and abroad, people have similar tastes. They like to eat this and dress in similar quantities, so that we get the following. So QF plus divided by QC. Actual international relative price. So in this case, what we have to check, so in other models, in nicer models, we don't get extreme situations where one country produces only one thing and the other produces only the other. So usually is one produces more of one, so more food than clothing, and the other more clothing than food, and they can trade. But in the Ricardian model, you're going to get extreme situation in which oftentimes one just produces one thing and the other produces just the other thing. So what you have to assume, so it's always the first thing you have to consider. So let's see if that happens. So first thing to consider. Both countries specialize completely in the production of so in that sense, so we say that since home comparative advantage in clothes and food, we said. So home only food and since foreign the comparative advantage in clothing uses only clothing. So then, so what do we know about this? Well, then QF, so F equals to 100 divided by AF. We get divided by 2, is that so? Yeah, it was 50. And we get, of course, that QC is 0, because that's what we were just saying, that home does not produce cloth whatsoever. And then abroad, we know that Q star F equals 0 and Q star C equals, so how many people live there? 150 divided by ANC. So that's equal to 9 by 5. So that's 15 then, so that's 30. By the way, you may have realized that I tend to use numbers that work. I may make a mistake and it may turn out that you get complete rubbish like 4 point this, but usually I try to make sure that you get somehow nice numbers, which means that in the exam, if you start finding complete rubbish, maybe I made a mistake, but yeah, double check your computation just in case. That's what I'm saying. That's a pro tip for you of taking my exams is I try to use a nice number. Okay, so now in that sense, we can just substitute everything. QF we said is 50. Q star F is 0. QC is 0, and Q star C is 30. And in that way, we would get, so let's find the relative prices. So I'm going to get simply this, so that's then the zeros, 30 disappears. Is it what I wanted? Yeah, 3/5. All right. So now the question is, so here I just said, first thing to consider, both countries specialize completely in the production of one good. How do I know that this assumption or this hypothesis was good? Well, I know if the price that I found lies within the prices that make sense. Otherwise, then it couldn't be the case that they both produce only what they want. Sorry, that they both specialize in their comparative advantage. Then I would have to find some other solution. If you want to find it, then look at the exercise I gave to you after lesson 2, I think. In that case, we found that that both countries didn't specialize. But in this case, you see that it works. So we find that PF over PC equals to 3/5. And I said here that yeah, between 2 and 1.6. And then, yeah, fifth is equal to 0.6. Oh, so is that, oh, and that's PC over PF, all right, sorry. Phew. Okay, so let's just write PC over PF. That's less complicated. PC over PF is going to be equal to 50 over 30. That's 5. So that's 1.6. All right. So it makes sense. So we're right at the frontier of the price range, but it works. Since 1.67, we have this, of course. We know that we see indeed to specialize. So it's not always the case that you find that it's just at the boundary. This is just because I use these numbers and this is what we get, but you could have gotten something different. Okay. So maybe now I got a bit further than some of you got, but so this is how you do it. Okay, and finally the tricky question, I think. So, at the international consume. Okay. So now home is trading. So we know that home is specializing completely in the production of food. So home is producing 50 food, but home is not consuming 50 food. Home is going to sell some of it to foreign and buy clothing in return. And since the price is different from the relative productivity initially, then hopefully home is going to be better off at the end. So know that. Specialize. Completely. In the food, in food production. Then sell this. You can imagine that it's just going to sell part of it, but it's also possible, since there's no trade cost or anything, it's somehow easier, I think, to imagine that home sells all of it on international market, gets some money, and then uses that money to buy, to rebuy some of its own production and buy some clothing as well, right? We sell this production to get money and buy on international market. Oh, I just thought of something interesting to ask you. Yeah, okay, it makes sense. I'll ask you a small question after. I just came up with it, so I think it makes sense. We'll think about it together. Okay, so it's production and get money at the international price, of course. So what you have to imagine is, like, I imagine I'm some farmer, I produced turnips. So I go to the village fair or the village market with my truck full of turnips. I sell these turnips and then I can buy whatever I want at the price that they sell it at the village. And then I come back home, right? So part of what I may want to consume later this night is turnips. But yeah, I'm going you can imagine I'm just going to buy back my own turnips at the exact same price I sold them. So how does that look like? Now the new constraint. So as we were saying, the constraint looks like this. So I have some money and I buy some quantity of clothing and food at the international market, PF and PC. And note that I don't exactly know what PF and PC are, and I don't exactly know what so M is going to be, but it does not matter. So M is the when I from let's say I'm not the one who's doing it, so home gets setting it's so m equals to what? So that's 50 times the price of food. So PF. Simply. So home goes to the market and sells its 50 units at the price of PF to get some bag of gold, M, and then uses that M to buy back some food and buy back some clothing. So the constraint is this. And then what I can do is just divide by PF everywhere, for instance. So I get this. So this is the new constraint I have. And now I can again using which was so it's the same as before, so I can say express QF as function of QC. So that's it. Oh, right. Sorry. So here it's not ALF, so that's PF. All right. Okay, so yeah, that makes more sense. So you see that these are the two are the same. So PC over PF, so times QC, so it's just 2 QC times PC over PF times 50. And then I get that. So 50 divided by 2, that's 25. And note again, I don't know what are PF and PC. Maybe it's 400, 300, and 500. I don't know. The only thing I know is that the ratio is PC over PF is 1.6. It's 3 over 5. So yeah, it's 3 over 5. So I get and then I can just substituting back. So I get oh, my computer has no electricity for some reason. Let me check. Okay, now it's plugged. All right, so then this is equal to 15. This is 3 over 5. That's equal to. Oh, is that so? I think. Yeah, 9. Is that so? Or am I mistaken? Seems very low. What did I? 15. Oh, no. Again, I inverted the. So that's, as I was saying, that's the confusing aspect of this is you always have to be super careful to not mess up. Okay. So we found it. So let us just show what we get. Just get rid of these. Now the new constraint is, as we were saying, is this one. So I can express it yeah, graphically. I can express it this way. So I can, what I want again is QC as function of QF. So multiplied by PF divided by PC. So that's PF over PC. Yes, 3 over 5. So this is 5, that's 10, so 30. Again, we can ask, so if C equals 0, then QF will be equal to, so QC equals 0, so QF is equal to this is 0. So again, that so divided by 3, that's 10. But yes, that's 50. F equals 50. And if QF equals 0, then QC equals to 30. So then now I have this new constraint. So let me show it on the same graph. So actually this one, this point is the same as what I had here. QF equals 50, QC equals 0. And now this one is 0, 30. So let's move this up a bit. So 25, 30 must be somewhere like here. So that's 12.5, 25. Yeah, it's not that high. more like let's this is constraint with trade. And the new consumption that we have found is QC equals 15. So before we had 12.5, so we're a bit higher. And QF is equal to 25. Yeah, okay, so we're still at 25, but we went up. All right. So that's the new consumption with okay. So I know I went a bit fast, but so time is ticking. It was a long assignment. So that's just question one. So is there other questions for this? Yeah, so I didn't do the last one. So let's do the last one. So, oh yeah, and I didn't say, yeah, I was going to ask. So how do you think things are going to change for foreign? So we know that home is better off instead, so it consumes the same quantity of food and more clothing. So do you have some idea what might happen in foreign? So it's that's a subtle question, but just take a minute to think about it. So I'm going to go up a bit, and yeah, so the answer is here. Think a bit about what this means there. I'm going to get some water because I've been talking for a while. Any idea? So my question basically is foreign going to be better off with trade than without trade? So I haven't shown you anything about foreign's utility or foreign's demand, although we can imagine it must look like home's demand. No clue.
I think that they would be better off as well, because if like they also specialize in their comparative advantage product, they would have similar advantages from it as home, I would suppose.
Yes, so that's a good thing to assume. But if I was to draw something similar in foreign, would there be yeah, so here what happens is at home you see that the production possibility frontier as, or rather not the production possibility frontier, but the consumption constraint in some ways has shifted up, because now with the new relative prices, then this is steeper than this. What about what happened in foreign? You know, so it's true that foreign is producing only one thing, but how did the relative price shift in foreign? And by the way, that's not something that always happened, but with the numbers I have, it just turned out this way. So I can tell you what the answer is. So foreign's relative prices before specializing were 1.66667, and after specialization, foreign's relative prices are again 1. So the international price is exactly the same. The relative price is exactly the same as relative productivity in foreign. So it means that, so if this, for instance, was foreign situation before, then after trade, foreign specializes completely in one thing, so probably there, but it's stuck on the same constraint as before because the relative prices are the same, so it's going to probably go back exactly to where it was before. So this is an extreme case, of course, but it really is an extreme case where I think, is foreign going to gain anything? No, I think not. Yeah, no, foreign is not going to gain anything, but that's just normally foreign would gain something and home would gain something. So, but since the relative prices are exactly the same as the relative production, so foreign is exactly indifferent between trading with home and not trading whatsoever. But so this is just really something special about this price. It turned out this way because I tried to use numbers that work well. So normally I would have chosen numbers. Yeah, if I chose numbers even like in between, then you would have gotten something like even flatter than this. And yeah, numbers are not don't work too well. So the last question is what was H, so express gains from trade has increased in utility. So that's quite easy to do. So everybody did the right thing. It's just you didn't have the right numbers there, but I hope now you will have them. So before trade. So at home was you had so what was in first? It was 2F. So then for trade I have here 25 and here 12.5. Yeah, so here it doesn't work well, sorry. And after trade, I have 15. I consume more, so I should be happier. Okay. Numbers. So we're happy. Okay, so yeah, we've been going for a while, but I can still continue a bit, or are you tired? Do you want to take a break or continue right away or continue tomorrow? Yeah, or tomorrow, right at this time, I can't, but I could do a bit later. How do you see it? I could just go on. No opinion?
I'm fine with both, like either continue or continue tomorrow.
Grégoire, Johan?
Yes, same for me. I mean,
So let me look at this. Uh, yeah, it's a bit long. So I'm starting to be a bit tired. How about we continue tomorrow at I think I have something at 3 tomorrow. So at 4:30, how about it? Would that work?
Demain, je suivrai en cours toute l'après-midi.
De quelle heure à quelle heure?
À 14h à 17.
14h à 16h?
À 17.
À 17. How about that?
Aujourd'hui?
So how about that? I take like a 10-minute break just to catch my breath, and then we go on and we do all of it. Would that work? Okay, so I take a 10-minute break and I come back and we finish. And we are back. So, all right. Number 2. Hexaroline. Fixed proportion. Now we consider only home. So we have A, F.
Excusez-moi, on n'a pas de partage d'écran.
Oh, yes, sorry. So extra adding with fixed proportion. So what's important is the resource requirements. So we have AKF equals 4, LF equals 1, and then AKC equals 2, 1, and else equals 2.
I just had a question for the exam.
Yeah.
Do we need a calculator?
Oh, yes.
Okay.
I hope that I can make it such that it's useless, but don't take any chance, bring one.
Okay.
So yeah, it's a good idea to bring one. Okay. Which good is relatively more labor intensive? Which is capital intensive. So to ask this, so to answer that, compare units of capital versus units of good of labor are needed. If one needs 10 units of capital for one labor and the other needs 1 for 10 labor, then you know that the first one is capital intensive, the second one is labor intensive. So let's look at what we have. So we have EK equals 4 divided by 1. So this looks capital intensive, but let's compare it to the other ones. For clothing, and AKC is 1 and ASC is 2. So yeah, we see that for food, we need 4 units of capital for 1 and then 1 for 2. So of course, Um, so food capital intensive. And very intensive. So obviously so even if that was like 10 and 20, so you would still say the same. So it's how much do I need to invest in terms of capital compared to labor, right? So the answer will change. So, so total capital stock is 1200. Let's not call them labor stock. Total number of workers, they're human being after all, is same quantity. Drop the PDF. Okay, so here essentially what we have is we are going to have two production possibility frontier that are linear, but the combination are going to give us something that's non-linear. Why? Because I need both labor and capital in both sectors to produce something. So I can use my labor in one or the other sector. I can use my capital in one or the other sector. So I just do the same as usual with capital on one hand, then with labor on the other hand. So capital constraint. Capital used in the food plus the capital used in clothing is going to be equal to the total capital. So that's 100. Yeah. So this is A QF plus times F plus AKC. Right, so I just do exactly the same as before, but now I have, so now it's for capital, but then there's this labor requirement as well. And yeah, I have 1,200 workers. I can substitute the numbers. So AKF is, as we were saying, form. AKC is 1. ALF is 1. ASC is 2. And I can even express them in the usual way that I like. Here, what did I say something about where I wanted the PPF? With clothing on the vertical axis. So again, I'm going to express QC as function of QF. So this so minus QF. And that's it. So that's my constraint for, that's my capital requirement. That's labor constraint. So let's divide both sides by 2. So I get 600. Okay, so I can draw this. Yeah, so this should start at 1200, then this I think should be at 1200. Just in case. So imagine that's, so that's 400, 800, 1200. Oh, by the way, am I sharing my screen properly? I think not. Yeah, I'm not.
We
hold
can
on.
see the calculation.
Yes, yes, that's why I just realized. So, oh, okay, here it is. So, yeah, I want on screen. Yes. Sorry about that. So, yeah, this is again 1200. So same trick as before. So let's draw this first one there, the capital constraint. So when QC equals 0, then QF equals 1200. So I know that I have this here. QC equals 0, QF. And when QF, QC equals, should write stuff on my axis. Put food and the vertical axis. No, clothing. Okay, so no mistake. What am I doing there? So I'm claiming that when QF equals 0, QC equals 1200. So no, yeah, this was right first. This is there. And then when QC equals 0, so this is 12 divided by 4, so 300. Oh, yeah, that's, I should have to divide this by 4. Not the best. Okay, let me draw it a bit better. I don't know if that's going to help later. We'll see. Okay, so now 4, and now this will be 300. So that And by the way, write somewhere that it's your capital constraint. Otherwise, it's confusing. So let's use, I think I use blue for that. That's capital constraint. And then labor constraint. So this is 0, this is 600. And this is 0, this is 12. Okay. And now, so one good thing is to show stuff on your axis. So yeah, we said that this is 600. And this is 10. And this is the labor constraint.
Excusez-moi, comment on fait pour avoir le 300?
Okay, yes. So 300 is 300, c'est le capital constraint. Donc je vais le montrer. Donc, si j'ai C égale 0, alors je vais avoir donc 0, je vais avoir donc 4, donc 200 divisé par 4, ça fait 300. Et sinon, si j'avais QF égale 0, alors j'aurais simplement, j'enlève ça et j'ai QC égale 2. Voilà. Donc ça me donne 2 points à chaque fois des intercepts. C'est comme ça que je le fais. Ça va?
Ah oui, j'ai juste calculé la mauvaise façon.
Pas de problème. En général, c'était pas mal bien fait, ça. La plupart des gens ont eu bien. OK. Donc voilà, on sait que maintenant la... OK, so what I'm saying is...
C'est possible de remonter juste un peu sur le tableau de gauche, un tout petit peu.
Comment? Ah, monter un peu?
Ouais.
Okay, and of course, what we're saying is that so to produce something, you need not just one thing to be okay, you need 2 things. So here, for instance, you would have enough capital because you're within the capital constraint, but you would need more labor than you have to produce that much clothing and that much food. So this wouldn't be attainable, this is not attainable, and this is not attainable because you don't have enough capital. So only this region there is attainable. And then I will. You don't have to do that. I like to draw it this way. Okay, so that's B, or that's A, right? No, that's B. No. No. Is, check the question. Can you see something about autarky relative prices of food in the price of food in this economy? Maybe. So what can we know about it? Well, so I don't know if I said something like, yeah, I gave somebody some insight or whatever, but basically what's going to happen is, so if you're in the Ricardian model, that one, then it's pretty easy. You're sure that the relative price is going to be the Prussian Pacific frontier. So minus ALF over ALC. Now it's not so clear because you see that you could be on that side or on that side or here. So I'm going to show you the three possibilities. So again, what you need is some sort of utility function, but I haven't drawn any, but so let's, or given you any, but still let's draw some. So for instance, you could have a utility function that looks like this. Yeah. Okay, this is a challenge. So if you have a utility function that looks like this, right? More or less. So then where would this economy be in autarky? Well, again, what you do is you maximize your utility while respecting your production possibility frontier. So you pick the point with on the frontier, which gives you the highest utility. So you have like one here, you may have one there, and you may have one below. So that one is unattainable because all of its points are beyond the production possibility frontier. That one is attainable, but you can see that, for instance, here you could do better by consuming more of food and clothing. So in the end, that one is going to be the winner. And what would be the relative prices for that one? Well, it's the marginal rate of substitution at the consumption. So it would be, so that would be the marginal rate of substitution. So that would be the relative price in this economy. So that would be one case. Now, some other case would be some other utility function. That would look like this. So that one would be possible too. And you see that the relative price in that case would be, and so would be exactly on this constraint. So that would be AL minus ALC over ALF, I think. I'll have to check. And then you could have a third one, you may guess, which would be down there. So these three cases are the only thing that you could have. Either something that's on the kink, something that's on this segment of the production possibility frontier, or something that's on this segment. So it has to be one of the three. And as you can see, so here the relative prices are represented with these relative requirements. So essentially the capital constraints. So PF over PC would be AKF over AKC. And in that case, it would be the labor constraints. So the PF over PC would be ALF over ALC. And in that case, also it would be in between the two, right? So this is what we're saying. So it could be somewhere. So yeah, so I would have that A and F, A and C. Right, so I have to check which is bigger. So AKF or AKC. No. That's not the case at all. What am I doing there? Okay, no, I'm confused. That's not how I should write. So it's okay. So that's ALF over ALC equals to 1 over 2. And okay, over AKC equals 4 over 1. Okay, so PF over AKC is greater or equal to PF over PC is greater or equal to PF. So that's 4. That's yeah. So that's okay. So that's a subtle point there with the utility curves, but so this is how you think about these things. So all of these questions that I asked in the exam, not the exam, but the homework, were, I would say, on the edge of your knowledge. So I made you work a bit for them, but yeah, some of you did quite well. So I was very happy with the result. So does that make sense? If it doesn't, yeah, I can drive over it more, but yeah, I think it's okay. Turkey. This equals numbers. And so that makes sense because I get PF over PC equals 1. So 1 is between 4 and 1.5. So we're good. Oh, I see it where I gave the hint about so where are we? And, here. So that's not a right question. So what would be is the autarky production of food. Well, now we know that. So the slope is 1 exactly. So this slope right there. So we cannot be on this side and we cannot be on that side. So we know exactly that we are on the kink, right? Because I'm looking at the relative prices and it means that the slope here is -1. So yeah, it's not exactly right. So anyways, the point is the same. So I'm exactly on the kink. So my utility curve is probably something like this. Right? So it so that's at the intersection of both the constraints. So, so how do we find it? Well, it's again two unknowns, QF and QC, but two equations, the capital constraint and the labor constraint. Let's use them. So let's substitute QC. Oh yeah, so I can just rewrite this. This equals to, so you see that QC is equal to this and QC is also equal to that. So it means that this is equal to that. There we go. And so let's multiply everything by 2. 8, 4, 24 minus. I have a bad tendency of erasing my steps, so all of them. So this minus 1200, that's 1200. And then this 8 minus 1, so this is plus 8, 8 minus 1, so 7. Wow, that looks very bad. Is it true that I gave this number? Okay, I didn't ask to compute it. Okay. So, and then we would get QC equals to, let's use this one. By the way, but congrats if you did. Okay, so that's D. So yeah, there's a lot of that. Probably if you have computation, it's going to be something like linear and yeah, not too difficult. I say probably. It doesn't mean you shouldn't worry about the rest, but yeah, it's hard enough as it is. So the point is not to so that's a basic rule of exams is whatever I ask you to compute. If there's like 3 steps or more, somebody is going to mess up the computation, and that's just sad. So, and then after that, I have to check. Oh yeah, but that was the answer in A. So then in B it becomes this, and in C, and it's just a mess for me too. So I try to avoid it as much as possible, and give something nice and easy to compute. Okay. Oh yeah, that was a neat one. This I found that on some other website about this this sort of model. I had no clue that we could even compute wages and rental rate, but yes, apparently we can. So let's go ahead and do that. So under fixed technology, fixed proportion. Profit representative firm. The food sector equals PF minus whatever it has to pay to produce. So that's a no, sorry, that's W times LF minus R times. So what does that mean there? So where this is the profit. Yes, is as a full. W is the rental rate. Is the right. R or the interest rate. LF is the labor used in food, and KF food. Similarly, we get for write this everywhere. Okay, so this is a profit. Why? Because I produce a certain quantity of food, I sell it at price PF, but then I have to pay the number of workers that produce that in my firm and the amount of capital that was used to produce it. Yeah, and this is a representative firm, so QF is actually the whole production of food. LF is the whole labor force used in food, and KF is the whole capital amount used in food as well. Same thing for clothing. And then the question is, under perfect competition, profits are 0. So why do we use this condition and not the condition that so why don't we use, for instance, optimization of profit, and we find that the marginal product of say, labor has to be equal to the marginal cost W? Well, in that case, that wouldn't work because everything is linear. So there's essentially you as you're going to see, you only have one very simple condition. So in that case, we can't take a derivative essentially. So but what we use is instead this condition there, so that profits are 0. So don't worry, I'm going to see rather either use profits are 0 or use profit maximization, in which case you would have something like probably some function that's different there than this simple function there for profits. So something like I've used previously in other classes. And there are free movements of capital and labor across sectors. It means that the wage rate has to be the same in both sectors. Otherwise, if workers are paid more in the clothing sector, they would all move there. Or if they're paying more in the food sector, they will all move there. So essentially it means that W here equals W there. So that's why I didn't write WC, for instance, and just wrote W. And same thing for capital. Resources. And yeah, and that's it really. So find W and so first step substitute LF AC. So we get this. That doesn't have to be the first step, but that's the first step. So LF is equal to QF to LF. F. And then second step, profits are 0. So I is for either F or C. So and then what do we have? We have, oh, and then we can also see that we can divide by QF everywhere and QC everywhere. So second step, divide by quantities. Oh yeah, no, it has to be the third step. Sorry. Second step. Otherwise, third step.
Excusez-moi, j'ai pas vu l'étape 2. C'est possible de remonter?
Ouais, Donc, l'étape 2, c'est simplement dire, comme on disait, c'est que en compétition pluriparfaite, les profits sont nuls. Donc, voilà.
Ok, ça marche.
And just a comment about this. So why do we have this? Well, essentially, it's because if profits were not zero, so if, for instance, PFQF was also, let me go there. So if profits were positive, then it means that so imagine that this is greater than 0. So that means that, so imagine it's equal to, I don't know, 10, right? So I would have that this whole thing over there would be equal to 10. But then you see that, as we were saying, you can, so you have QF, QF, QF. And what does that mean for the firm? Then if this is 10, then what quantity should I choose for QF? Well, if I double QF, then I get a profit of 20. If I triple or quadruple or multiply by 1 million, I get 1 million times more profit. So in the end, what would be the optimal choice? It would be to have an infinite quantity produced. So we don't want that. Or rather, if profits are negative, then in that case, what would be the best QF possible? Where it would be to produce absolutely nothing. So that way profits would be actually 0. So to not have either an infinite quantity or a 0 quantity, the only thing that is compatible with the model where QF has some finite number is to have PF minus WAL, LF minus RAFKF to be equal to 0. So in that case, so I can choose whatever QF I like because I already know what QF I want. It's this one over there. It was that one. So otherwise, it wouldn't be rational for the firm to choose something else. So obviously, it's a very simple model, and it looks a bit ad hoc the way I justify it. But so you cannot have positive profit. That's for sure. In the long run, anyways, you don't have positive profits because firm can enter the market and blah, blah, blah. So you want 0 profit. Okay, so that's what we have. So now we get, again, 2 equations, 2 unknowns. So let's use one to solve the other, so I can get something like W. And then we can, let's go back to the second one. So now it's just again computation. So minus plus. All right. So let's have right. All that has to be returned to the that side. So if I put it on this side, then I'm going to have either this minus this. So then the rental rate. All right. So what can I do? Let's multiply by ALF on both sides, right? So ALF, or not on both sides, but above and below. And ALF, ALF. Oh, did I do? I think I made something weird. Let's try again. ALF, ALF, ALF. This is fine. This goes over with this, and this goes over with that. What I got seems like a complicated formula. Yeah, I think that's what I got. Or rather, I divided stuff in different ways, but yeah, okay. So let's just input numbers. So ALF was 1. PC was 5. PF was 5 too, I think. ALC was I think that's 2. EKF was 4. And AKC was, oh yes, was 1. So yeah, so that's a tedious one, but still I find it awesome that you're able to find the rental rate and the wage rate in such a simple model. Kudos to people who found that. Yeah, I think among you, some people got it. Yeah, so let's use this to find again wage rate. Seven. PF was, what was it, 5, and ALF was 1. AKF was 4. Okay. So yeah, I didn't ask for any interpretation, but can you interpret what does that mean exactly? So this means, oh yeah, well actually later on yeah, it doesn't mean a lot if we can't compare it to anything. So, but yeah, so F we are asked to compare it to something. So let's go ahead and F. looking from things. If the stock capital what theorem does that demonstrate? So I didn't say much about what was the quantity. So yeah, just visually, what do we see? So let's do that. So if the stock of capital increases, so what happens to my capital constraint? Well, it's less constraining. So it increases this way. Let's see, green. And so what happens? Well, and oh yeah, and by the way, the relative prices. What does that illustrate? So it's the strange. So, what do we see on the graph? We see this thing going on. Yeah, so rather I'm going to show it this way. So we see that QC increases and increases. This illustrates the, oh yeah, that one is super interesting to write. The rib. So what nationality is this? Is this like Polish or something? Or Russian? Something like that. Theorem. So that's a theorem that's very, very special to this circumstance. When you have this model with fixed proportions and two constraints. So in that special case, when the capital constraints increases, then you're going to find that you produce more of the if the constraint on the capital, if the of capital is less stringent, then the capital intensive if will produce. So that's true in this circumstance, but I'm not too sure it's true in all cases, but it's true for this this specific model. All right, and this is F, and this is G. Okay. Suppose the economy opens to trade. International relative price. No, the international prices are PC equals $3. If equals $5. Why? Because in the world is relatively more abundant. So that's why the labor-intensive good, cloth, is cheaper. All right. So in that case, compute the rate, the wage rate. And capital rate there then so essentially so now we don't care about consumption. What we're saying is we're going to open up to trade and produce as best we can, so to make the maximum money. So again, the only thing that's going to change is PC and PF. So before we had PC and PF that were dictated by internal consumption. Now PC and PF are going to be dictated by world prices. So they are the world prices, and we produce accordingly. So let's just go back here and do it again. So yeah, I'm not going to do that. So only thing that's changed is PC is that one and PF is that one. So 5 and 5. That became PC is 3. Okay. So I get 1, which is lower or higher? Higher than 5/5. And LW is equal to so what's changed is R, which is now 1. And PF is the same or not? Yeah, PF is still the same, still 5. So I get 1 again. 1, which is smaller than 15 over 7. So what does that mean? It means that the capital becomes more remunerated. Because is at the world level. But liberal becomes less because there is more competition for labor. That's illustration of the Stopper-Samuelson theorem. All right, so that's I think that's it. So again, to illustrate this last fact, so why did we say this? Well, because the price of cloth declined. So if the price of cloth at the world level is cheaper than at home, that's because at the world level, they have more of what's limiting for cloth, which is workers. So that's why they're cheaper. So then it makes sense for home to focus more on what's, well, in that case, I'm guessing that they're still going to be to produce at the kink, but still it's going to affect the relative, so the remuneration of capital and the remuneration of workers. Okay, so other questions? Oh, I haven't saved this. Let me save right away.
So one question regarding the exam. So we can expect the math questions to be similar like the homework we just did, right?
Okay, so I'm seeing that some of you are quite comfortable with math, some less. So it would be very mean of me to start asking weird questions that you even haven't tried on your own in the homework. So yes, I'm going to try to not stray too far away from what we just did there in terms of mathematics. Yeah. Or so I did give you some exercises. So I might ask you something not too complicated related to some exercise I gave you in the past. Don't worry about the last set of questions I gave you. So I don't know if you tried them or not. So the last set of questions about monopoly and oligopoly, and so that question about the App Store. Anyways, so if you haven't tried them, I was kind of full of hope before this Monday, last Monday, and hoping that we could maybe see them in class. But they're super fun. I wish people try them one day, but yeah, I'm not going to ask you something too far away.
Okay, thank you.
My pleasure. All right, so just to say this.
C'est possible, je voulais savoir en termes de répartition des points, vous estimez à peu près s'il y a une maîtrise des exercices qu'on a eu là dans ce devoir, approximativement, ça représente à peu près combien de pourcentage du devoir qu'on aura?
Je ne l'ai pas terminé. D'habitude, dans mes examens, je fais un tiers questions de cours et 2 tiers questions plus de maths. Là, je vais faire un effort pour mettre plus de questions de cours et moins de questions de maths, encore une fois, pour pas que ce soit, soit trop lourd. Donc, ouais, je vais essayer de faire 50-50 ou si j'arrive, même encore plus de questions de cours, mais bon, je trouve c'est pas facile de poser des questions de cours qui soient genre OK, ou bien souvent elles sont ultra difficiles et très, très spécifiques, ou bien c'est un peu des platitudes que tout le monde sait. Donc, je vais essayer de poser des questions de cours intéressantes. Ouais. Donc, disons, visez 50-50 et si vous avez un peu de chance, il y aura peut-être encore un peu moins que ça de questions de maths.
Ok, par rapport aux questions de cours, c'est vraiment tout ce qu'on a vu dans les chapitres de 1 à 6.
Ouais, tout ce qu'on a fait, c'est.
Il y a des points sur lesquels vous allez plus vous concentrer peut-être?
Ben, OK. Je peux rien vous dire, mais je vais vous dire comment je réfléchirais si j'étais un étudiant. Alors, j'irai par déduction. Et je me dis, ben, le prof, il vient de nous dire qu'il ne va pas te poser des questions ultra compliquées de maths, surtout sur le dernier chapitre avec la compétition imparfaite et tout le machin. Donc, il n'a pas trop le choix de poser des questions de maths sur les 2-3 premiers chapitres qu'on a fait. Donc, s'il pose plein de questions là-dessus, à la fin, il n'y aura pas trop le choix de poser des questions de cours un peu sur la fin, parce que la fin, sinon, on ne va pas en parler du tout. Donc, c'est comme ça que je vois le truc. Et comme je vous dis, je ne l'ai pas encore écrit. Peut-être que j'aurai des inspirations pour une question X et Z dans une section. Je vais voir. Donc, je ne réponds pas parfaitement parce qu'à la fin, ce que vous essayez de
Non,
me
bien sûr.
demander, c'est qu'est-ce que je ne peux pas apprendre? Il faut tout apprendre, mais bon, voilà.
On essaie de faire le maximum. En tout cas, et est-ce que c'est possible de revenir sur certains aspects de ce qu'on vient de voir aujourd'hui?
Oui, sûrement. Ouais. C'est bien pour ça. Donc, allez-y.
J'ai eu, je ne sais pas s'il y a d'autres gens qui veulent peut-être poser des questions, s'ils veulent, entre guillemets, se libérer ou s'ils veulent revoir tout avec nous.
Allez-y.
Ok, ça marche. Alors, c'était à partir de l'étape 3, quand on a commencé à diviser par les quantités, j'ai noté un truc, je n'ai pas suivi et après, j'ai eu mal pour la suite à…
D'accord. Donc, ça, l'étape 3, c'est pour la question 2 ou question 1?
C'est ça, oui, sur la question 2.
Question 2. 1, 2. Ah, step 1, step 2, step 3?
Oui, il y avait…
D'accord, ça, c'est pas très difficile. C'est regarder simplement. Donc, step 1, alors je vais substituer
Pour moi, le problème, c'est vraiment à partir de la 3, mon problème. J'avais compris,
Ouais.
j'avais compris avant, j'avais compris la logique.
Et donc,
J'ai
voilà, après tout ce que, ouais,
on a au-dessus.
donc, tout ce que vous faites, c'est ici, vous voyez, vous avez QF, 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 QC, QC, QC. Donc, tout ça, c'est égal à 0. Donc, on peut diviser simplement par QF ici, par QC là.
Ok, mais pourquoi en fait, je comprends pas la logique.
Ben, parce que ce qu'on cherche, ce que j'ai demandé ici, c'est trouver find W and R. Donc, je vous demande de trouver W et R. Parce que ça, on l'a déjà, QF et QC, on sait déjà, on est ici. Donc là, ce que je demande, c'est de trouver W et R. Donc, ce que vous essayez de faire, c'est d'éliminer le max de variables qui ne sont pas utiles pour finalement arriver à trouver juste une expression pour W et pour R. Donc, vous voyez que là, vous avez une expression avec des QF et une expression avec des QC. Mais donc,
Ok,
ça c'est juste des chiffres qu'on n'a pas, enfin, on les a déjà de toute façon, et ils ne nous intéressent pas. Donc on a égal à 0. Donc, on peut simplement diviser par QC ici et diviser par QF là. Et comme ça, on obtient ces expressions qui sont super simples.
ok. En fait, si on les remplace par les données qu'on a, c'est là où ça va compliquer les choses, c'est ça?
Non, mais c'est juste que regarde, c'est juste pas utile. Donc, QF, par exemple, on l'a déjà calculé, c'était 1210 par 7. Donc, je pourrais substituer 1210 par 7 partout, par exemple. Là, là, là. Mais c'est pas. Après, de toute façon, je vais les récanceller parce que ça va juste me donner les gros chiffres ici, mais ils vont disparaître à la fin.
Ok, d'accord.
Donc, on veut les
Et
faire
ensuite,
disparaître le plus vite possible.
ok. Je suis en train de regarder comment on a trouvé la constante du W, du R. C'était par rapport à quelle formule?
Ben, c'est ça. Donc,
Ah,
une fois qu'on a ça, vous voyez que ce qu'on a, c'est PF, c'est une donnée que je vous ai donnée. ALF, c'est une constante aussi, c'est une donnée que je vous ai donnée. Et AKF aussi. AKC, ALC et PC, c'est toutes des données que je vous ai données. Donc, à la fin, il y a quoi qui reste à trouver là-dedans? Il reste W qui est inconnu et R qui est inconnu. Donc, comme d'habitude, ce qu'on va faire, c'est essayer de, par exemple, exprimer, ici, ce que je fais, j'exprime W en fonction, j'utilise ça, j'exprime
ok,
W en
d'accord.
fonction du reste, et ensuite, je substitue W là-dedans, et ça me donne une expression où il n'y a que R. Et ensuite, je peux remplacer, trouver que R, c'est égal à 5 septièmes.
Ok, d'accord.
Il n'était pas facile, hein, celui-là, parce que je ne l'ai jamais fait en cours. Hein. Ça, je me suis dit, est-ce qu'ils vont le à la fin, c'est un devoir, donc ils vont travailler un peu et avec un peu de chance, ils vont l'avoir. Mais je comprends si ce n'est pas évident.
Ok, et après, concernant le graphique, qu'est-ce que ça donne? Parce qu'en fait, quand j'ai été perdu, j'étais un peu perdu pour la suite. En fait.
Ah, OK. Mais il ne fallait pas hésiter à me dire. Hein. Donc, je peux continuer avec vous. Donc,
C'est vraiment
voilà,
en
là, on trouve R et W.
Ok.
D'accord. Et là, donc, c'est F qui vous donne du souci, non?
Ouais, bah oui,
C'est ça.
la
Donc,
suite.
F, c'est starting from D. Alors, D, c'était le graphique, je crois. Ah non, c'était pas le graphique, c'était.
Parce qu'on vient de
C'est pas
passer
grave, mais
avec.
bref, starting from D, ça veut dire, donc, bref, c'est à partir de ce qu'on a trouvé à D. Donc, à D, on a trouvé que ceci, c'était l'équilibre. Voilà, c'était la quantité qui allait être consommée de food et de capital. Ensuite, je dis, qu'est-ce qui arrive si le stock de capital augmente? Alors, si le stock de capital augmente, ben, ça ne bouge pas parce que c'est la contrainte qui vient du nombre de travailleurs qu'on a. Donc, on a toujours le même nombre de travailleurs, donc le truc ne change pas. Mais si le capital augmente, alors ça, cette contrainte va être shiftée vers la droite parce que, bref, j'ai plus de capital avec lequel travailler. Donc, par exemple, si ma quantité de capital doublait, ben, ici, au lieu d'être 300, j'aurais 600 et au lieu d'être 1200, j'aurais 2400. Donc, voilà, c'est shifté vers la droite. Et je n'ai pas dit de quoi, j'ai juste dit si ça augmente, alors qu'est-ce que ça donne sur qu'est-ce qui va se passer?
Excusez-moi, j'ai eu du mal.
Donc,
J'essaie de comprendre en fait ce qu'on avait écrit en D.
en D, c'est simplement que je demandais où on va être.
En D, ce qu'on avait, c'était le calcul de QF et QC et de supposer qu'on était dans un système en autarcie
Oui, c'est
avec
ça. Exact.
C et F est égal à $5. Maintenant, comment on en est arrivé au graphique?
En fait, donc, le truc, c'est qu'il faut déduire que pour comprendre ce qui se passe, il faudrait utiliser le graphique. Parce que si je vous dis juste quand le capital augmente, qu'est-ce qui se passe, ben, en fait, c'est toujours un bon réflexe de se faire un graphique et de regarder ce qui se passe sur le graphique. Comme ça nous aide à comprendre et à ne pas faire d'erreur.
OK.
Et donc là, on voit, donc sur le graphique, on voit bien que si le capital augmente, donc cette contrainte va vers la droite. Est-ce que vous comprenez ça ou non?
Enfin, si je comprends sur le capital, moi, pour l'instant, ce que je cherche à comprendre, c'est comment tracer ces lignes et d'où, en fait, on les a prises. J'avais mon graphique ici et j'ai du mal à voir, en fait, quand je reprends la question D et que je vois QF et QC, j'ai du mal à savoir, en fait, je dois refaire une équation pour mettre égal à 0 pour savoir combien est égal QF et QC pour tracer la ligne, c'est ça?
Ben, en fait, oui, c'est ça. Si je vous avais dit what happens if the stock of capital doubles, par exemple. Si j'avais écrit double, ben alors vous auriez dit, ah ben très bien, je sais quoi faire. Je reprends ma contrainte sur le capital que j'ai tracée en utilisant cette équation. Oui, c'est vraiment long ce
Dans quelle partie que j'ai mes notes aussi.
voilà, c'est... Ah, c'est ça ici. Donc ça, c'est la contrainte sur le capital. QC égale 1200 moins 4 QF. Donc si je vous avais dit, par exemple, la quantité de capital double, alors qu'est-ce que ça veut dire? Ben, je sais que j'ai une quantité de capital égale 1200. Donc là, j'aurais une quantité de capital égale 2400. Donc, ma nouvelle contrainte aurait été 2400 moins 4F. Donc, ça aurait été vraiment, genre, j'aurais parti à 2400 ici et j'aurais été à 600 ici. Et donc, mais là, je n'étais pas intéressé par que vous me disiez exact quel va être le chiffre d'équilibre, mais juste qu'est-ce qui va se passer. Donc, vous me dites tout ce que vous pouvez me dire en fonction de ce que je vous de l'information que je vous donne. Alors, tout ce que je vous dis ici, c'est le capital augmente, qu'est-ce qui va se passer avec la quantité d'équilibre, sachant que le prix relatif ne change pas. Donc, vu que le prix relatif ne change pas, ben, on va toujours être au kink. Donc, on va être au kink, mais simplement au nouveau kink qui est... Attendez, j'ai un peu mal dessiné. Donc, le nouveau kink.
OK, mais on n'a pas du tout à estimer le nouveau QF. On doit juste estimer
ouais, c'est ça.
ce qui se passe.
Exactement.
OK.
Mais j'aurais pu vous dire ça aussi, j'aurais pu vous... Mais à un moment, c'est pas hyper intéressant de calculer. Sauf que, en fait, ce qui est bien, pourquoi est-ce que je ne l'ai pas demandé dans ce cas-là, c'est parce que tout est très visible visuellement, vous voyez?
Oui, bien sûr.
Par contre, pour l'autre, ça n'aurait pas été... C'est pas évident du tout de voir ce qui va arriver, vous voyez, au dernier. Là, au dernier, je dis qu'est-ce qui arrive quand les prix relatifs changent. Donc, au lieu d'être 5,5, c'est 3,5. Ben, si vous regardez sur le graphique, il n'y a rien qui arrive. Vous voyez, c'est tout ce que ce serait, c'est qu'au lieu d'être comme ça aurait été un peu plus... ça aurait été comme ça, 3,5 à peu près. Sauf qu'en fait, donc, probablement qu'on serait resté au kink encore, moi j'en sais rien, mais probablement. Alors, on ne peut rien voir sur W et R. Donc, c'est pour ça que je vous ai dit, bon, ben voilà. Alors, le prix PC change, recalculez R avec le nouveau chiffre, recalculez W avec le nouveau chiffre, et dites-moi comment ça a changé. Et donc, c'est pour ça que je l'ai fait comme ça.
OK. Donc, à la fin, je regarde juste, en recalculant le nouveau R et en calculant le nouveau W, on peut calculer justement la deuxième la droite de la nouvelle constante de capital.
Oui, c'est ça. Ben, justement, là, R et W, ce n'est pas du tout visible sur le graphique. Donc, tout ce que je peux vous dire, c'est le prix change, quel sera le nouveau R, quel sera le nouveau W, mais on ne peut pas vraiment le voir sur le graphique.
OK.
Ça aurait été le marché des inputs, mais là, donc vraiment, ça sur un très, très simple modèle, donc il n'y a pas de grande interprétation.
OK, donc ça, c'est le résumé de la question F.
Ça, c'était G, là, de quoi je parlais, mais donc F, tout ce que c'était de dire si le capital augmente, et
La
que
quantité de...
l'historique ne change pas. Ouais. Et donc, tout ce qu'on dit, c'est qu'on voit que, donc, au nouvel équilibre, donc, QC a diminué, donc il y a moins de cloth qui est produit, et QF augmente, il y a plus de food. Alors, pourquoi? Ben, parce que parce que le food est intense en capital, donc si j'ai plus de capital, j'en fais plus, tout simplement.
OK.
Et ça, c'est le Ripsinski theorem. Je veux savoir Ripsinski.
Comment?
Moi, je dis juste, je vais voir Ripsinski, c'était de quelle nationalité. Moi, je serais prêt à mettre 20 $ sur Pologne.
Est-ce que c'est possible d'avoir
Polish
peut-être
born. Allez-y, allez-y.
d'avoir des exercices pour pouvoir s'entraîner?
J'en ai donné à la fin des cours, mais ouais, je vous avoue que comme c'est la première fois que je donne le cours, j'ai pas vraiment de banque d'exercices d'accumuler plus. En fait, ça a pris déjà du temps de faire les. Donc, ce que je vous recommande, en fait, c'est ce que je peux vous recommander déjà, c'est de juste essayer de voir ce qu'on a fait là. Et ensuite de dire, bon, ben, je vais recommencer à zéro et je vais essayer de faire chaque question par moi-même sans regarder la correction, juste de mémoire. Donc, ça a l'air un peu pas très, pas très créatif, mais juste l'apprendre par cœur comme ça, ça peut être très utile pour acquérir des réflexes et dire, ah oui, quand on me demande ça, c'est généralement ça qu'il faut faire. Et à la fin, le genre d'exercice que je pourrais vous donner, ce serait exactement la même chose, mais avec des chiffres un peu différents, par exemple. Donc, si vous voulez un autre exercice pour Ricardo, j'en ai donné un à la fin du cours 1, il est sur Moodle. Et pour l'autre aussi, j'en ai pour le fixe.
Dans le processus. C'est pas encore. Exactement.
Pour le Specific Factor Model, j'en ai aussi donné que j'avais corrigé en classe au cours 3, je crois, au cours 4. Donc, vous pouvez regarder ça aussi. Non, mais je suis désolé, j'en ai
Excusez-moi,
pas.
je n'ai pas entendu, j'ai été coupé.
Ce que je voulais dire, c'est que, donc, c'est ça. À quel moment est-ce que vous avez été coupé?
J'ai été coupé. Vous m'avez dit de pouvoir refaire les exercices à blanc.
Oui, donc c'est ça. Refaites l'exercice à blanc. Ou si vous voulez un autre exercice sur Ricardo, j'en ai donné un dans le cours. Et en fait, je pense que j'en ai donné sur tous les trois. En fait, vraiment, je vais accentuer les exercices sur les trois gros chapitres, donc ou bien le modèle de Ricardo, ou bien le modèle le specific factor, le deuxième qu'on a vu, ou bien le Caroline, le troisième, donc celui-là.
Ou bien, ou bien quoi, c'est quoi le... Je n'ai pas entendu.
Caroline. Attendez.
OK, OK.
Ouais, alors, vous voyez ici, j'ai des exercices sur le Specific Factor Model. Exercice sur le modèle de Ricardo. Exercice sur Imperfect Competition and Trade. Celui-là, bon, je ne vous le recommande pas chaudement parce qu'ils sont assez difficiles. Je pense que je n'ai pas mis la correction pour celui-là, le Specific Factor Model. Je vais voir si je n'ai pas la correction, puis je vais essayer de l'ajouter en dessous. Donc, peut-être que vous vous souviendrez, c'est un truc que j'avais fait en cours. Voilà, comme ça. Donc voilà. Désolé, j'en ai pas plus sous la main, mais peut-être sur Internet, vous pourrez essayer d'en trouver. Peut-être, je vais essayer d'en chercher et voir si je peux en trouver. Je vais écrire au peu si j'en trouve. Mais à la fin, il ne faut pas. Je vais pas être, comme je vous dis, je vais pas inventer des trucs qui sont trop différents de ce que vous venez de faire. Donc, est-ce qu'il y a d'autres questions? Are there any other questions?
No, I think it's good for me. So
Alina?
No, I also don't have any questions. Thank you.
Okay, so
yeah, thank you a lot for your time.
my pleasure. Well, I didn't have a lot of takers for office hours and in the rest of the semester, but I knew that I would get more at when the exam would come. So. All right.
Thank you.
Thanks a lot.
Peut-être une petite dernière question. Est-ce que avant la fin de la semaine, vous pensez avoir un temps pour faire un Zoom comme celui-là?
Oui, vendredi, ça vous irait?
Tout dépend de l'heure.
À quelle heure vous irez?
Alors, si je ne me trompe pas, j'ai cours du matin jusqu'à 17h.
Oh ouais, c'est une bonne journée pour vous. Ou alors, ouais, jeudi, c'est pas top pour moi. Ouais, donc, ça vous embêterait de faire vendredi à genre 17h30?
Ah non, du tout. Moi, je...
D'accord, donc on peut se fixer vendredi 17h.
Good evening.
So I'm saying that I'm going to have a Zoom with Johan on Friday. So if you want Zoom, yeah, I can offer Zoom meetings to help.
So is it for everyone to join or?
Well, I mean, I'm not going to be to favor somebody. Johan, qu'est-ce que vous planifiez de me demander? C'est des trucs particuliers ou
Non, ce que je vais faire, c'est que je vais retravailler encore, je vais refaire des exercices de mon côté et puis je reviendrai encore vers vous avec les endroits où ça coince et où les endroits où je ne comprends pas. Après, maintenant, s'il y a d'autres gens qui veulent se joindre à nous, moi, j'ai aucun problème. S'il y a des gens aussi qui veulent peut-être s'entraîner même avec moi, j'ai encore aucun problème. J'avoue que avoir quand même des difficultés dans cette matière, donc la coopération ne me dérange pas du tout. Si ça permet à l'un ou l'autre de mieux expliquer ou de mieux comprendre, voilà.
Okay, so I think I'll do that. So Zoom at 5:30 on Friday. Yeah, I think I'm good. Yeah, I'm okay. 5:30 on Friday. So come with your questions again, last minute questions. And so Johan is the one who asked me first, so he's going to start with his question, and eventually I'm going to have other questions. So I'm going to write it for everybody. Does that look like it could be good for you? Yes. Okay, I'll note that. Yes, I'm totally aware that you're not economists and the step is just intense. So plus I would say that sadly for you, I'm an economist that really like to link like graphs with explanation and math, so blend the three of them. So maybe I do more maths than other would the similar situation, but yeah, that's the way I teach. Sorry. So I'm going to write Zoom.
Just a question for the other people. Are you guys want to try to work together on something, or you want to work in chacun de son côté?
I don't know if I will have much time this week to work with people since I'm a bit busy. So I think I'm gonna more like work on my own. So that's what I think.
Okay. About Elena, it's the same.
I am open to work together, but we have the same classes with Grégoire. So we have classes on Wednesday and Thursday and on Friday the whole day. So it might be a bit like a time issue, but maybe we can like exchange numbers and then we can write about time that would work for both of us.
Okay.
Okay, so anyways, I'm going to let you plan your things and eat some stuff. You guys can write in the chat, right? So yeah, so just before leaving, so bye everybody.
Okay, goodbye.
Goodbye.
Goodbye. So just if you need to write stuff, I'm going to wait for 5 minutes to before ending the thing.